Hello, my name is Hermann Rauth. I'm field application engineer in the area of code testing within Vector Informatik. And in this presentation, I'm going to talk about our code testing tools for static and dynamic software testing, which help enforcing safety standard compliance for the standard EN 50716, which is the successor of the older standards EN 50128 and EN 50657, which are combined together in this new standard, which has been released in 2023. Like other safety standards for automotive or industrial, the railways safety standard is also derived from the IEC 61508. All these standards have in common that they emphasize software lifecycle processes, which where validation and verification, of course, plays a critical role. What does validation actually means? It's a question about, are we building the product, the right product? So this can be ensured in the end in the user acceptance test. Of course, the user needs to check whether the application, the product we build, does what it expects to be. Or earlier in the process, we can use system testing of automated testing, whether we test the software in loop or we use hardware in the loop testing to automate system level testing. Of course, things like performance testing and beta testing are also part of validation. In the verification phase, we actually ask the question, are we building the product right? So this is about review and inspections and static analysis to enforce coding standard compliance, and unit testing to test portions of the code, modules, components dynamically to see that those are functional and do behave as expected. In general, one can say it's all about quality, software quality, that the safety is given by our product. So coming to the validation phase, you have your existing system test with your source files, your build process to build the executable, then to flash or run the executable either on host when it's in a virtualized environment, or flash it to target when we are using the real hardware. In this scenario, we can use VectorCAST QA to instrument the source files before the existing build process picks up the instrumented source files, and we build an instrumented version of the binary. Then after execution of our test cases, we can grab the code coverage and create reports out of those. In case we store the coverage information for each test case individually, VectorCAST is able to identify test cases which need to be re-exercised after source code change. We call this feature change-based testing. So this can reduce the test cycle dramatically depending on how small the code change is and how many test cases you have in general, of course. For the verification, we are asked to perform static code analysis. We offer PC-lint Plus as a tool for the static code analysis. It's a command line tool and can be integrated in IDEs. I do not want to list all the features of the tool. I thought it's maybe more interesting to take a look how this could work. So I will show PC-lint Plus inside VS Code. This is a very simple code example. It doesn't really do something meaningful, but we can see how things work or look like when we work in Visual Studio Code writing some code. I added PC-lint Plus as a task and we can use the task runner to initiate the analysis of PC-lint Plus from our C file we are currently working on. After the execution of, or after PC-lint Plus analyzed the code, it provides the data in an appropriate format that VS Code is able to show it in the problems section of the tool. So all this, what you see, is built in with Visual Studio Code, but PC-lint Plus provided the data accordingly that it can be displayed that way in VS Code. You can see we can jump inside the code to different messages. We can also use the filter to filter out some specific messages as you like. But of course, we can also look into findings inside the code, which are marked with the curly line underneath. Here you see one message I introduced myself, so it's a user-defined message. I used a query, one of more than 100 queries which are available within PC-lint Plus. And in here, I wanted to enforce naming conventions. Each unsigned variable should start with a small u. So this helps reducing the effort for code review, because PC-lint Plus is able to check the naming in this example, for instance. Then I used the metrics feature of PC-lint Plus to enforce comment density. It's also a user-defined message I use in here. There are more than 100 metrics available you can use on the code under test. Of course, we can also check for the coding standards. In this case, we see a warning from CWE. It shows that we cause a memory leak because we override the pointer with another address, even we allocated some memory before, and we lose the pointer to this memory. In the upcoming version of PC-lint Plus, we are going to introduce a dashboard. This is more meant to be part of or used in a CI build server environment scenario. So we run the analysis on the server on the code, and we can see how it evolves over the build runs. We can also take a look at the findings in detail, and you can filter out like which standards we checked, and just showing the MISA-C findings. And then we can also take a look at the code itself and the finding inside the code. And in case you would like to get more information about the findings and how what it's about, we added a link to the specifications, and you can read through the documentation. In this example, the CWE description of the finding. Further, we can create reports. So in this example, I use an Excel format for the report. I did this up beforehand to save some time. So you get an overview about the project, how many findings we have, which coding standards we checked, and how much findings there are. You can also dig deeper into the individual findings. And you can also take a look at the summary with how many lines of code we have, functions, findings, and so on, to get a better overview for reporting. So let's continue with verification, but the dynamic software test. So in the software unit test, when we would like to test one function isolated and run it, we need to have a main and a test driver calling the function under test, setting some values before calling the function. After returning from the function, we need to verify it against expected values. Usually, we use external functions in our code. We need to have some replacement code in order to be able to compile and link. We call those stubs. Some call those mocks or fake functions. So VectorCAST, our tool for unit level testing in this case, VectorCAST C++, creates all the stuff you see in the light gray box, the domain, the driver, and all the steps which are needed to compile and link it to a binary. This binary can run on host when we use a host compiler, and on target if we use the target cross compiler for the target, obviously. And again, I would like to show the tool instead of listing all the features. So let's jump into VectorCAST. You see here a so-called VectorCAST project. It's meant to get an overview, but it's also meant to maintain all the settings we need and are unique for all the test environments we have. We can run the wizard out of the project, and you see that some steps are already pre-filled. The only thing we need to provide is a name for it, and then select one C file. All the other settings are already given by the project. When I press on build, VectorCAST is now pre-processing the code, parsing the code, generating all code which is needed, what I explained before, and then compiling and linking everything all together. And in the end, we get an executable. In my case, I use a Windows compiler, host compiler, and you see I get a Windows executable which can be exercised on command line right away. So now we have a test environment with the name we selected, with our unit under test, which is the manager.c, and with all the functions implemented within our C file. Now we can easily create a new test case. And we see now the function under test with its parameters. In the when we are dealing with safety and we are in the safety project, we are actually asked to provide a traceability, requirements traceability. So I imported requirements from Polarian, and we are able to link the new test case to a requirement. We can also take a brief look at the description. So this function should return 14 euros in case we order a steak. So it's a restaurant example function, which is easy to understand for everybody. So now let's briefly fill some values. And you see that VectorCAST understood the code, and the third parameter is a struct. It consists of those elements, all are enums, and we also have the enum symbols available to create the test case. As mentioned, it should return 14 euros. And we can also use stubs, which are used by the functions, to validate data or to give data back into the function. So let's say we would like to ensure that the place order function really stores the 14 euros on table 1 inside the database. That's now quite easy test case, calling the function under test with specific input values and expected values. We can now run this, and you really see we execute the code, and we get an execution report stating that we called the function with those parameters. We checked that the stub called by place order function provides the correct values, and in the end we returned with the correct value. We have a passing test case. Let's briefly check the code coverage we generated. So in here we see all the green lines are already covered code, and the red ones obviously are not yet covered. And of course, we went through the steak case. When it comes to safety-related projects, we are asked to gain as much coverage as possible. 100% would be nice to show that we do not have dead code which is not used or useless or maybe harm something. In case you're not able to run this code through a test case, so you cannot execute it, you might want to add a justification to tell the authority this code is on purpose, written on purpose due to specific reasons, and you can just provide a document telling that it's okay to have this code which is not exercised. In VectorCAST, we have a feature which is called add coverage analysis. And then you can just mark those lines you would like to cover manually, so to say, and provide a description with the reason and an explanation. Maybe you would like to also add a date when you did this and who did this and so on. And this way you can provide the justification out of the tool and gain more coverage. Let's briefly take a look at a report, at a full report. We see all sorts of things. We also see the test case we saw before with the execution report. It looks pretty much the same as in the tool. And in the metrics, you see now that we have aggregated coverage on the one test case we had and on the justification with the analysis, and the justification right next to it that the authority sees which lines of code are actually justified manually. The nice thing about using this feature is in case the code moves up and down, you add some more code in front of it or remove, then VectorCAST keeps track on those lines. So this is actually all for now. Of course, there are a lot more features to be shown, but the time is not that much we have. So let's briefly sum up. I showed our code testing tools, PC-lint Plus for static code analysis, enforcing coding standard compliance like MISRA and CWE, and using queries and a metrics feature to introduce user-defined checks. And I showed VectorCAST to measure code coverage in system-level testing and creating unit tests for dynamically tests. Both tools are certified to be used in safety-related projects. Thank you very much for listening. And I'm curious about your questions now in the upcoming Q&A session. Thank you very much.